Saxon's Calculus, Lesson 58, is about derivatives of trigonometric functions, and then a summary of the rules for derivatives and differentials. All right, so in Part A, they want us to actually derive a lot of the formulas that you have possibly, well, some of them I know you've already been told. So in example 1, it says, use the fact that the derivative of sine gives you cosine to find what cosine is. Well, we already have memorized that cosine goes to negative sine. So they want you to use the fact that trig comes from right triangles. And if you call this one theta, then this one is 90 minus theta, although they're using pi over 2 minus theta because they're using it in radians. That was the right angle part. Now, they also have to use, in order to do this, a u substitution. And I don't wish to go through all of these derives because you have already started to memorize. But if you really want to see how they do them, again, example 1 and 2 and 3 and 4 and 5, I think, are all ones where we're going to stuff that you can just memorize the formula for. But if you are interested in how they're doing it, by all means, go through those examples. So example 1, we already know cosine goes to negative sine. Example 2, use the quotient rule, which is your low d high minus high d low over square of what's below, and sine and cosine to find the derivative of tangent. So tangent of theta goes to secant squared theta. And I don't think you'd already gotten that one from before. But you can see here in example 2 how they just followed the low d high minus high d low over square of what's below and did a little bit of algebra simplification and got to secant squared. Example 3, use the quotient rule, same one I just said, and the derivatives of sine and cosine, which you already know, to find the derivative of cotangent. This one they said x, not that it matters. All right, so we're going to jump to the fact that it is negative cosecant squared x is the memorized formula. And again, they're just following high d low minus low d high over square of what's below and doing some algebra simplification and getting to that answer. Example 4. Use the fact that secant x is the reciprocal of cosine to find the derivative of secant. Was that x? Yes, secant x. All right, so secant is, of course, 1 over cosine, which you can then write as cosine to the negative first power. Now do a u substitution and simplify, and it's not as straightforward. It's actually secant x tangent x. Example 5. Use the fact that cosecant x is the reciprocal of sine to derive cosecant of x. And as you would expect, you're going to write that as sine to the negative first and do the same u substitution they just did in the last one and manipulate it down. Your answer is negative cosecant x multiplying with cotangent x. Now, example 6 finally is asking you to use the rules that we just found. So it says if y equals e to the x multiplying with secant x plus secant squared x, find dy over dx. So we need to follow our multiply. So I really don't have room to do it here, but I'm going to do it anyway. 1 e to the x, derivative of secant. Well, we just found that that was, secant x tangent x. So 1d2 plus 2. So there's our secant x. Oh, and I should be putting, they're all x's. It's automatically going to be dy over dx. Okay, 1d2 plus 2d1, which is still e to the x, multiplying with that, plus, and then secant squared is going to be, okay, so it's almost like a u substitution. because I'm going to put the 2 in front, and that's going to take me down to secant of x. But that secant was secant x tangent x. So the original secant with this secant will get you secant squared and then the tangent x. So just to repeat again, what I did here was in my head did a u substitution, and I said u is secant. So u squared is 2 secant x when I derive it. And then the secant being derived was secant tangent, so there were 2 secants, and that's how I ended up here. Now, I don't think I can put anything together. E to the x was secant x, tangent x plus, yep, the e to the x should be in front, secant x. They didn't put it that way, plus the 2, secant, yes, okay. Even though I crammed it in there, that is the answer. Example 7, if y equals x squared, tangent x, plus cosecant squared x, find y prime. All right, so I'm not going to cram it in this time. We're going to give ourselves space. All right, so again, 1d2, so x squared, and then the derivative of tangent is secant squared x, even though that says theta, we're doing the x's because that's what we have here. 1d2 plus 2, so tangent of x, with the derivative of the first one, which goes to 2x, 1d2 plus 2d1 plus cosecant squared, and again, I'm going to make that 2 with the cosecant, and the cosecant gave me negative cosecant, so that's going to be negative here, then cosecant squared x with the cotangent of x. Double checking, x squared, secant, 2x should be in front, yes, and then the minus 2 cosecant, yes. Okay. Example 8. If y equals natural log of x cosecant x, find dy over dx. So thankfully I don't have as many parts this time, but I do have 2 things that are multiplying. So 1, natural log of x, going with the derivative of cosecant, which was negative cosecant x cotangent x, 1d2 plus 2. So rewriting cosecant x multiplying with the derivative of natural log, which is the 1 over x. And I probably should rearrange the order a little bit, but just note that this would be negative with the natural log, the cosecant, the cotangent. The 1 over x should be in front and cosecant x. Example 9. If y equals tangent cubed x over e to the x plus 1, find y prime. All right, so now because this is a division 1 quotient, I need to follow the other song. So low, e to the x plus 1, deriving tangent cubed. Ooh, okay, so again, it's a u substitution in here at the same time. So it's going to be 3 with the tangent, I may have to write this one out, 3 tangent squared x is that derivative, but that is multiplying with the tangent derived, which was secant squared x. Okay, so low d high, the 3 to the squared, and the tangent. Okay, low d high minus high, so tangent cubed x, high d low. So the derivative of this one is e to the x, the 1 goes away, all over the square of what was below. Oh, they start getting complicated. All right, so now 3 should be in front of the ex plus 1 and the tangent squared and the secant squared minus, and the e to the x should be in front of the tangent cubed, but there we go. Now part B. Whew! They take all of the formulas that you know and they list them on page 291. So what I would do, these are the new ones. And so I noted that those are the new ones that should be memorized, but the rest of them you should already know. But I would also kind of dog ear that page in my book if I have not put it in my notes to use it as a quick reference spot every single time you need to be using these.